Hello everyone. Today I will be explaining Slido window technique. So it's a technique that is used to find maximum sum of subarrays of size k. That which subarray of size k has the maximum sum. So let's start with a random array of some random elements. I have chosen the size as 8, and for k let's assume it to be a 3. That we want to find that which subarray of size 3 has the maximum sum. So what we'll do, first we will take the first 3 elements, then we will move to next 3 elements finding their sums, and we will store their sum to some other vector or array. So you can see that I have made an animation down there which stores the sum of all the subarrays of size k. So by taking every 3 elements, we will finally reach at a subarray of size 6 in which all the sums are stored. Now finding its max, we receive a result of 19. So we know that the maximum subarray sum of size k is 19. Now for complexity analysis, the total complexity is O of n square. Now coming to the sliding window technique, we will use some different method. So first of all, we will take the same array and we will take the same k, that is equal to 3. Now we will take the first window of 3 elements, compute its sums, and again computing the sum of all the array, we will subtract the sum of first element and increment it by the last element. So for this, the next element gets added and the previous one gets subtracted. So in one operation, we computed the sum of next window. And why it's happening? Because while we are shifting the window and k minus 1 elements are same, they are not changing. So we just need to compute the edge elements, and through this technique we got the same summation array in the end, and now we can compute max and it will give it the same value. But this time we have a slight change in complexity. So if we analyze the complexity, it's O of n instead of O of n square. Now we will see Kadane's algorithm, which is an algorithm to find the maximum subarray sum of any size. So here we will not limit our k to 3 or any value. Here it can be any value. So normally we can do it in n square using brute force, but let's see how we do here. So we have a random array or consisting of negative elements as well. Now we will maintain two other values, that's current sum and maximum sum. So current sum is equal to what we take from the element for the first time. So as we can see in the animation, that when we move to next element, we compare it from upside, that's the element, and from the left side, the previous sum. So whenever we encounter negative value in the cur sum, we will discard it at 0. Here I have written it -2, but total of the formula is that maximum of current value and maximum from previous value. So where we can get the maximum, we will take it from there. And the max sum implies what is the maximum summation we have seen up till now. So it's increasing. You can easily guess it. That is the monotony function. It will always increase. So whenever we encounter a max value that's greater than the previous max, we will update it. And current sum, we will check that is it increment on like adding the previous value or not. So by this method, when we reach at the last point, we have our final max sum, that's max sum n minus 1. Also there is another technique in which we can subtract the minimum prefix sum to find the same answer, but it's a bonus part, you can solve it. So complexity analysis of Kadane algorithm, its complexity is O of n, we are transversing it only once. Thank you so much.